Let's talk about why current measurement matters. The meter only tells you the truth if you put the leads in the right place. Technicians often try to see if the power supply has enough amps. Measuring in the wrong spot gives misleading results. Before you measure, know what you're measuring and why. Current flows, it doesn't wait. Voltage is measured across a load. Current is measured through a circuit. The meter must be in series to read the current flow. Each device shares supply voltage, but draws its own current from the circuit. Where to place the meter leads. Current must be measured in series with the NAC circuit. At the panel output terminals, gives you the total NAC current. Between the panel and the first device, you still get the total circuit current of that NAC. Between two devices, only the downstream device current. Across the terminals in parallel gives you a false reading. You could blow your meter fuse or cause other damage. Don't do that. If all NAC current does not pass through the meter, you are not measuring the full load. How current changes along a NAC run. Panel output goes to device 1, 2, 3, 4, 5, 6, and eventually hits the end-of-line resistor. In our example, each device draws 0.1 amps in alarm. At the panel terminals, you'll read 0.6 amps. Between devices 1 and 2, you'll read 0.5 amps. 2 and 3, you get 0.4. 3 and 4, 0.3. 4 and 5, 0.2. And between 5 and 6, you get 0.1 amps. In our example, we have the 6 notification devices in parallel. Those are horn strobes. Each device draws 0.1 amps. This is just a suggestion or an example. You'll have to look at what your horn strobes actually draw. So 0.1 amps at 24 volts. 6 devices total is 0.6 amps of load. Now our NAC circuit might be rated at 3 amps total. Measuring between device 5 and 6 shows only 0.1 amp. Measure at the panel output or before the first device to verify total circuit current. The 3 amp illusion. The panel NAC might be rated for 3 amps. Your measured load on that circuit might only be 0.6 amps. Plenty of headroom there, it seems. That doesn't prove the proper voltage at the last device. Acceptable voltage drop, correct conductor size, system margin under full load. Rated capacity is not proof of performance. We have other calculations that we'll have to do to make sure that the circuit is capable of powering every device. Amp rating is not equal to load demand. The supply does not push amps, it allows them. A 3 amp NAC power supply rating means capacity, not output. Loads draw what they need, the panel provides it. Measuring mid-circuit is not equal to total load. A higher amp NAC will not correct a voltage drop. Wire resistance causes loss along the run. A fire alarm NAC circuit reality. Notification appliances are wired in parallel along one circuit. Each device draws its own current. All device currents combine at the panel output. 6 strobes at 100 milliamps each, or 0.1 amps, is 0.6 amps total, or 600 milliamps. Measuring between devices shows only the devices downstream of that point. Measure at the panel to verify total demand. Concept: current must pass through the meter to be measured correctly. The cause: loads draw amperage. The supply only allows what the circuit demands. Effect: measuring in the wrong location creates false confidence, and amp rating does not guarantee proper voltage at the last device. Know where the current flows. That's where the truth is measured.